example number 8, they will say to us, we are supposed to determine the gradient when x is equal to 2. What are we supposed to determine? We're supposed to determine the gradient when x is equal to 2. Now, here's what Elena is given. What is the Elena given here? The Elena is given f of x. If Elena takes f of x and then they substitute it here, the Elena is not going to be able to get a gradient. What is the Elena going to get? What is the Elena going to get if they take and then just substitute them? If Elena takes 2 and then substitute it here, what they are going to be getting is y value. So if you say f of 2, shoot everywhere now one upon x is over 1 or 2. But the answer that you're going to get is not m, is what it's y. So you can write it in a coordinate form. Remember when we're getting our points in, we say which we have x no. Where is what? So when x is equal to 2, but who's allowed? When x is equal to 2, they can ask you what is y. What are you going to say then? So okay, we are going to have 2 all cubed minus 2 all squared plus 3. And then you can type this in your calculator and check what you get. What you get? You get 8 minus 8 plus 3, which is going to give us what? 3. So when x is equal to 2, our y is going to be equal to what? To 3. That's not what they are looking for, child. Huh? It's minus 4. It's 3. 8, child. 8. Okay. So what does this say? It says when x is 2, our y is going to be equal to what? To 3. That's the story. When x is equal to 2, our y is going to be equal to what? To 3. Yes, Zim. Yes. Huh? A second derivative, it negates what we call a point of inflection, which is something that we are not dealing with much. The gradient, it negates that. First derivative, it negates the gradient. And then a second derivative, it negates what we call a point of inflection. So we'll get to that at a later stage. What is it that they're looking for here? They're looking for determine the gradient. Gradient, key point, key wave. But what is the key wave there? And then what is the key wave here? It's a gradient. So if Elena is looking for the gradient, it means what they are going to be talking about f prime of x. They're not talking about f of x. Once you see the word key, gradient, we are not talking about f of x, but we're not talking about what? F prime of x. How do you get f prime of x? Remember, we already know how to differentiate it. We differentiate 3 multiplied by 1. What is 3 multiplied by 1? 3x squared. We are more 3x squared to be a differentiation from rules. And then uzobanu 2 multiplied by minus 2. Minus 4x. And x is a constant. So what is this? This is the gradient of this curve. It's just the gradient of this curve. They don't want the gradient of the curve. They want the gradient when x is equal to what? To 2. They are a bit specific. We don't want the gradient of the curve. We want the gradient when x is equal to what? To 2. So how am I going to get the gradient when x is equal to 2? I'm going to say f prime of 2. Not f of x, f prime of what? Of 2. What does f prime of 2 gives me? It gives me the gradient. What does f of x gives me? It gives me 1. What do they want when they want the gradient? So the gradient of this thing here is going to be given as 3 multiplied by 2 all squared minus 4 multiplied by what? By 2. If you do this, you have 12 minus 8, which is going to be what? To be 4. So what does this mean then? It means when x is equal to 2, it has 2 things. It has the y value, which is 3. It has the gradient, which is what? Which is 4. So this one I then do, I then say to learners should know which they have 2 things. They have the point, which is we can call it point P. They also have another point. At the same time, they're also going to have another point. Actually, we can draw a rough sketch of this thing. It's a cubic function. So let's say which we're at x is equal to 2. At x is equal to 2 somewhere here. At x is equal to 2 here, we have a point. The point is, 2 is to 3. When x is 2, our y is equal to what? To 3. What else do we have? Same time. We also have another thing here. Let's erase this one so that it doesn't confuse us. I only want this one. So what else do we have here? We also have another point which I call P prime. What is point P prime? It speaks about x and the what and the gradient. The x value doesn't change. What changes is the m and the what and the y. Where do we get y? We get it from f of x. Where do we get m? We get m from the what? From the f prime of x. So what is going to be this point? This point that I'm talking about, which is point P prime, is going to be what? What is point P prime? Point P prime, it says, which is, 2 hamsalano 4. Point P is, we have 2 hamsalano 3. So we have x and y, we have x and the what and the gradient. Let's try the following, child. Determine the gradient of the tangent. Now it's a tangent, it's a point which is going to touch this thing only once, touching the curve only once.